We're going to look at how HEEDS and plant simulation can be used together in order to optimize a factory layout. Let's suppose that we want to tune the capacities of these buffers in this car manufacturing plant. To begin with, we need to define the inputs and outputs that HEEDS is going to change and measure. We do this using the experiment manager. Our input values are the buffer sizes. 4 of them have already been done for us. So we'll create an extra row, drag on the 5th buffer, specify that we want to edit the capacity, and give the parameter a name. Then just click apply, and that's done. Now we need to tell HEEDS which output to measure. We're trying to maximize the throughput. So we'll take the drain, specify the throughput per hour, give it a name. As we won't actually be running an optimization through the experiment manager, there's no need to tell it that high values are better. We just click apply. OK. Now we're going to tell HEEDS what the baseline values are. So we're just going to create a single experiment in the manager with all these buffers at 5, which we'll use as the baseline buffer capacity. That's applied. Now all we need to do is make sure that HEEDS knows where to find this experiment manager. We do that by going into the information flow and duplicating this variable. And a variable has now appeared here under user objects. We're going to take it and move it to the basis. And we're going to rename it plant sim 2 HEEDS. We open it up, turn it into an object, and make sure the value of that object is this experiment manager. The experiment manager is called HEEDS Optimization. Now we just need to save the model, and we're done. In HEEDS, we create ourselves a new project. It comes with a default analysis. We want to tell it to use the plant simulation portal, which we can do like so. Now we need to tell it to use the plant simulation file that we've just saved. So we just take that file and drag it here into the input file windows. We'll continue without auto-tagging the file for now. Now we connect HEEDS to the input and output parameters we defined in plant simulation. Let's select the input file in the tagging window. All the buffer capacities that we specified are listed here, along with the names that we gave them. We'll use auto-tagging to make this quicker. We just select the 5 buffer capacities, and parameters will automatically be generated and connected in HEEDS. The minimum buffer capacity should be 1. We can copy and paste between these cells. Let's use a maximum buffer capacity of 20. Because HEEDS will assess so many options so quickly, we can afford to be generous and a bit more experimental than we might be if we were doing a study like this manually. We'll also set all the resolutions to 20 so that it can try every integer value between 1 and 20. Let's finish up. These parameters now are in this variables window and have automatically been generated as we specified. We need some responses too. Selecting the output file, And now we can see the throughput output we created. We can tag it like that. We want to maximize throughput, but we also want to make sure that the buffer capacities aren't too large. We're going to create a response that will monitor the total buffer capacity size. This should be a formula response. The formula is a simple one. It's just the sum of all these input parameters. Apply that formula and we're ready to go. Let's set up the study. We want parameter optimization, but we need to define some objectives. We want to maximize the throughput and we want to minimize the total buffer size. In order to get a range of solutions representing all the possible trade-offs between these two objectives, we're going to tell HEEDS to run a multiple objective trade-off study and generate a Pareto front. We have relatively few variables, so we only need 150 or so evaluations, and we'll get by with an archive size of 10. We could probably use fewer evaluations, but because these simulations aren't very resource intensive, we might as well err on the side of caution and use a high number. A final check of variables and responses, and we're ready to run the study. We can see the designs being submitted and completing one by one. There are plots being generated automatically, and we can watch as new designs are assessed and values for throughput and total buffer capacity are calculated for each one. Now that the study's complete, we can take a look at the results. Switch HEEDS into post mode and create a 2D relation plot to see the trade-off between the two objectives. On the x-axis we'll look at the total buffer capacity, and on the y-axis the throughput. Here we have a clearly defined Pareto front.